What's up, everybody? Mr. Kozad back with another video lesson. Hope you're doing well. Just to remind you, no matter where you are, no matter what you're doing or how you found us, today is a great day to be alive. I got to tell you that. Today is a great day to be alive, no matter your circumstance, no matter where you are. Just decide that today's a great day. You're lucky to be here. And we are just so lucky to be together talking about some Algebra 2. I know you love it. Today's lesson is on graphing reciprocal functions. We'll talk about what this word reciprocal means. If you are one of my students, this is section 8.3 in our textbook. So here we go. Let's jump right in. So all you need for today is something to write with and something to write on and a good attitude because we're about to have some fun. Here we go. So the reason I kept this page on here is I want to point out to you that the goal here is for you to be able to draw these graphs and find these attributes with no calculator. We're going to try to do this sans calculator without a calculator, so push yourself to do that. I know that at home it might be easy for you to use a calculator because you're not in class, but push yourself to try to learn how to do this with no calculator because your pre-cal teacher next year will expect you to be able to do this without a calculator. So here we go. Let's jump in. Okay, so the first thing that we're going to do is talk about the parent function of the reciprocal family, okay? And the parent function of that family is 1 over x, 1 over x. We call this a rational function because our variable is in the denominator. And this is called a reciprocal function because x is linear and there is no x in the numerator. So linear term in the denominator, no variable term in the numerator, just a number, just a constant, okay? So let's go through some of the basics here on this. First of all, let's talk about the general shape of this graph. Now, I'm actually going to go in a little bit different order here. I'm sorry if that's going to give you some anxiety, but you'll get over it, okay? First thing I'm going to do is I'm going to do the type of graph, okay? The type of graph, this is called a hyperbola, okay? It's called a hyperbola, and hyperbolas are basically a function that's split into two symmetric pieces that are not connected, okay? So you'll see what that means when we actually draw this graph. Now, the next key attribute of basically all rational functions is the fact that there are two asymptotes. There's a vertical asymptote and a horizontal asymptote. And if you remember from past lessons, this word asymptote is sort of like a boundary line, okay, that restricts the movement or the location of some of those parts of the graph, okay? So vertical asymptote is going to go this way, horizontal asymptote is going to go this way, okay? Now, for the parent function, the vertical asymptote is x equals 0 because, remember, x is not allowed to equal 0. If, in fact, x equaled 0, we would have a 0 in the denominator of a fraction, which is a big no-no. We cannot do that, okay? And the horizontal asymptote for the parent function is y equals 0. Because there is no x value that you could ever pick to plug in this expression that would get this to equal 0. It's impossible. So y can never equal 0. So let's come over to the graph and let's plot those two asymptotes. So I've got y equals 0 and x equals 0. Okay? Now, the next thing that you need to know about this function is there's going to be two branches, and a lot of times to find the two branches, we're going to take some x values and plug them in, okay? So I'm going to plug x equals 1 in for x. When I do that, that's simple. 1 over 1 equals 1. So let's plot that point. 1, 1 is a point on the graph. Let's also maybe pick negative 1. So when I plug negative 1 in for x, y equals negative 1. So I plot that point as well. Okay, so what that does is that helps me see the location of the two branches of this graph. So I'm going to draw branch 1 up here in quadrant 1, and it's going to be a curve that looks like this. Sorry, that's a bad curve. Let me try again. It's going to be a curve that looks like this. Now, what you have to remember is as these curves approach the asymptotes, remember they get very, very close to those asymptotes, but they don't ever actually touch. And I'm going to say this a couple times throughout the day. Remember that the asymptote acts like a magnet. The asymptote acts like a magnet. It's going to draw the ends of the branches to itself. So this horizontal asymptote here, y equals 0, as we move this branch out to the right, it's like a magnet. The force of this asymptote is going to draw that end to itself. Okay, so think of the asymptotes like magnets. Okay, now the second branch is going to be over here in quadrant 3, and it's going to be the exact same shape because they're symmetrical. Okay, and again, remember that the asymptotes are like magnets. So the end of those lines, the end of that branch, gets infinitely closer to that asymptote, but it never actually touches. Okay, so then the last two pieces, our last two attributes that we have to talk about are our domain and our range. Now, the domain and range, the first time you see it might be a little tricky for you, okay? But it's not that bad moving forward. So with the domain, you're asking yourself, what x values are we allowed to use in this function, okay? So we start all the way on the left at negative infinity, okay? And then as we go from left to right, negative infinity, we don't hit our first problem until we get to here, okay? So x can't be 0. So the way we write that in interval notation is we go negative infinity to 0 with a parenthesis because we can't equal 0. We can approach 0, but we can't actually touch 0. We don't equal 0. Now, what I have written represents half of the domain. There's a second half of x values that we can use as well. We've got to figure out how to get these x values over here. So the way that we do two parts in interval notation is we do a union, which is just a u, and then we get our second part. Second part starts on the other side of 0 and goes to positive infinity. So that is what my domain looks like, negative infinity to 0, and then 0 to infinity, where 0 is not included, okay? Another way that you could say that is all real numbers except for 0. Now, the range here, we're going to approach it the same way. Range, we go from floor to ceiling. Okay, so we start on the bottom. What's the smallest y value that we have? Negative infinity. And what is the y value where we have our first problem? It's right here, y equals 0. Union, we skip to the other side of 0, and we go up to positive infinity. So the domain and range for almost all of these functions are going to have at least two parts. Okay, they're going to have at least two parts. All right, now let's talk specifically about some transformations, okay? Now, this is really important to look at here, okay? This is basically what the most complicated type of reciprocal function is going to look like. So if I actually plugged some numbers into that, it could look like f of x equals 2 over 3 times x minus 1 plus 4. Something along those lines is as complicated as reciprocal functions get, okay? And if you're one of my students, we've talked about transformations all year long, okay? So these should be familiar to you. It's the same transformations that have been happening before, okay? So I'll let you look those over here. I don't need to talk through each one of those, but these are the same transformations that we've been using all year long, okay? All right, so let's jump in and talk about some of these attributes here. Okay, now before I start, there's a lot of words on these slides, okay? You may not necessarily need to write down everything you see, but I really tried to break this down to step by step because I tried really hard to get you to a point where you can figure out a systematic way to approach this. So I'm going to break it down into steps. There's lots of words here. Like I said, if you don't really want to write down all the words, you don't necessarily have to, but definitely start with the steps. Okay, so step 1 is to find the asymptotes. Remember from our 2 slides ago that there will be 2 asymptotes. There's going to be a vertical and a horizontal. So we're going to find the vertical asymptote first. And here's the process that you're going to use to find the vertical asymptote every single time. You're going to take the denominator and you're going to set it equal to 0. Okay, so it's super easy on this problem. We're literally going to take x plus 2, set it equal to 0, and solve. We get x equals negative 2. Now remember, we are trying to find the x that makes that denominator equal to 0 because that's the x value that's excluded. So x equals negative 2, we are never allowed to use x equals negative 2 because if I were to use it, I would get a 0 in the denominator of that fraction, which is a big no-no. So we would say that x equals negative 2 is the vertical asymptote. I abbreviate vertical asymptote as VA. So you'll see that a lot throughout the next few lessons. So x equals negative 2 is the vertical asymptote. Okay? Now, step 1 continued. Now we'll find the horizontal asymptote. Okay? Now, finding the horizontal asymptote in our next lesson, 8.4, gets a little complicated. But for 8.3, when we just have reciprocal functions, it's pretty straightforward. Okay, it's a pretty straightforward process. So here, what you're going to do for reciprocal functions only is you're going to take the k value of the original function. So let me go back. The k value was -3. So we're going to write that out as an equation. Y equals -3 is the horizontal asymptote. Again, I abbreviate that. HA, ha, horizontal asymptote. Okay, that one's super easy. Again, this step gets complicated in our next lesson, but for today, it's super, super easy to find the horizontal asymptote. Okay. All right, so step 2, okay, we found our 2 asymptotes. Step 2 says sketch the asymptotes on the graph using dashed lines. Okay, so I'm going to do that. So my 2 asymptotes were at x equals -3. I'm sorry, y equals -3. I know that didn't feel right when I said it. Okay, so I graphed that line, and then I believe it was x equals -2. So there are my 2 asymptotes, okay, my 2 asymptotes. So step 3 says sketch the 2 branches, okay, of the graph using a test point if necessary. Each graph will have 2 symmetrical branches in opposite quadrants, okay? What that means is I'm either going to have a branch here and here, or a branch here and here. They'll always be in opposite quadrants, okay? So what I'm going to do next is I'm going to make a table of values. Remember, we're trying to do this without a calculator. Okay, excuse me, and we're going to just plug and chug. We're going to plug in some values. So let's see what happens when I plug in -1 for x. Okay, when I plug -1 in for x, let me actually just rewrite that equation. So it was 2 over x plus 2 minus 3. This is going to help me when I plug and chug. So I'm going to take -1 and I'm going to plug it in for x here and see what I get. All right, so -1 plus 2 is +1. So 2 divided by 1 is 2. 2 minus 3 gives me -1. So there's a point right there that we'll graph. So when x equals -1, y equals -1. Now that point alone gives me a clue. It tells me that one of the branches is going to be here, and the second branch should be over here in this quadrant. Okay, so let's pick a few more test points just to make sure. Let's plug in 0 for x, which is again finding the y-intercept. So 0 plus 2 is 2. 2 divided by 2 is 1. 1 minus 3 gives me -2. So the y-intercept here is going to be 0, -2. I'll plot a point there as well. Okay, so I feel pretty comfortable drawing this branch that's going to be in this quadrant here. Now, when you draw these branches, remember that the asymptotes act like magnets. They're going to draw the ends to themselves. So as you draw this, the end should get really, really, really close to the asymptotes. Remember, the asymptotes are like magnets. They draw the ends of these branches to themselves, okay? So now we know that the second branch is going to be somewhere in this quadrant, okay? But we're going to, it's a good idea to use some test points just to see, okay? So let's pick a x value that's to the left of -2. Let's try x equals -3. Okay, so when I plug in -3 for x, I get -1 on the bottom. 2 divided by -1 is -2. -2 minus 3 gives me -5. So there's a point right there. -1, 2, 3, 1, 2, 3, 4, 5. Plot that point. Okay. Now, I feel pretty comfortable with that point being able to draw this second branch. Okay. Remember that the asymptotes are like magnets. They draw the ends to each other, okay? Another way that you can check yourself is you look at each asymptote, and the arrows should be going opposite directions for those branches, okay? One branch goes up, one branch goes down, okay? At each of the vertical asymptotes, one branch goes up, one branch goes down, okay? So that is how we would do a problem like this. Okay, now step 4 is going to be using the graph to write out our domain and range, sort of like we talked about with the parent function. Okay, so for the domain, you know the domain started at -infinity, And let's go back and look. So the first and only x value where we have problems is x equals -2. Okay? So for our domain, we're going to go from -infinity to -2, union -2 to infinity. Remember, basically what this is saying is you're going from -infinity to positive infinity, but -2 is the only x value where you have problems. Now, for the range of this graph, remember range goes from floor to ceiling. So we're going to go from the smallest y value to the maximum y value. Okay? So the range goes from -infinity all the way up to the one place where we have a problem is right here. That's y equals -3. So we go from -infinity to -3, and then we get from -3 to infinity. There's our domain and our range. Okay? So those 4 steps is how you're going to put it all together and graph a reciprocal function. Okay? So now, example 2, we're going to do it all together at once. We're not going to spread it out as much as we did that first problem. So here we go. Graph the function and state the domain and range. Show the coordinates of at least 3 points. Okay, so that just means that we're going to make a table and show at least 3 points in our table. Okay, so here's the plan. Step 1 is to identify your asymptotes. So what we did on the first problem is we found the vertical asymptote first. Okay, and remember the process for finding the vertical asymptote. You take the denominator and set it equal to 0. So when you do that, you end up getting x equals 2 as your vertical asymptote. So I'm going to plot that on my graph as I go. Okay. Next, the horizontal asymptote. Okay, for reciprocal functions that look like this. Okay, you can just take the k value as your horizontal asymptote. So that's going to be y equals -1. Okay, if you're thinking to yourself, man, this is pretty easy. You're right. So far, it is pretty easy. Okay. All right, now next order of business is I'm going to make a table of values here. Okay, I'm going to make a table of values where I pick some x values and some y values, and I plug those in. Okay, so when I pick x and y values, I usually try to start somewhere close to the vertical asymptote. So since the vertical asymptote's at 2, I'm going to plug in a 3 for x, just to see what's happening on this part of the graph. Okay, so if I plug a 3 in for x, 4 divided by 3 minus 2 is 1, so 4 divided by 1 is 4. 4 minus 1 is 3. Okay, so there's a point right there, 3, 3. So I'm going to plot that on my graph, 1, 2, 3, 1, 2, 3. Okay, now remember this point, the location tells you a hint. That tells you that this branch is going to be in this quadrant, which means the second branch is going to be over here somewhere, if we did that first point correctly. So let's pick another point. Let's try x equals 4 and see what happens. So 4 divided by 4 minus 2 is 2. So 4 divided by 2 is 2. 2 minus 1 is 1. So when x equals 4, y equals 1. 1, 2, 3, 4. Okay, I like where this is going. Okay, I like where this is going. Let's do one more. Let's try 6. Okay. Okay, so 6 minus 2 is 4. 4 divided by 4 is 1. 1 minus 1 is 0. So there's your x-intercept, 6, 0. So 1, 2, 3, 4, 5, 6. Plot a point there. I feel really comfortable with that number of points, so I can draw this branch. And remember that as you approach the asymptotes, it's like a magnet. Those ends get drawn to the asymptote. Okay. Now, like I said, since this branch is in this first quadrant here, the second branch is going to be in this quadrant. But let's find some test points to be able to draw a relatively accurate graph on that. So let's plug in 0 for x and see what happens. So 4 divided by -2 is -2. -2 minus 1 is -3. Okay, that was a pretty easy point. So when x is 0, y is 1, 2, 3 down here. I'd feel better if we had maybe 1 or 2 more points. So let's try x equals 1. So when x equals 1, you have 1 minus 2 is -1. 4 divided by -1 is -4. minus 1 gives me negative 5. Okay, so there's another point. X equals 1, y equals negative 1, 2, 3, 4, 5. Okay, and let's just maybe get one more point. Let's try x equals negative 1 and see what we get. So negative 1 minus 2 is negative 3. Okay, 4 divided by negative 3. Ooh, that's not as convenient as it could have been. Okay, but that's okay. We can roll with it. So that's negative 4/3. So negative 4/3 minus 3/3 would be negative 7/3, which is a little more than 2. Okay, so if we plotted that point, we go negative 1, negative 1, negative 2, a little bit more negative than negative 2. So those 3 points, I feel pretty comfortable to be able to draw a sketch of this branch here. Remember that as you approach the asymptotes, treat the asymptotes like a magnet. Okay, and then the last thing that we'll do here is write out our domain and our range. Okay, so the domain is from negative infinity to 2, union 2 to infinity. The range goes from the floor, negative infinity, all the way up to the horizontal asymptote. And then you go from the other side of the horizontal asymptote all the way up to positive infinity. Okay? All right, another one that I'd like you to try. What I really think would be a good idea for you is to pause the video now and try example 3 by yourself. Try it, write out all the attributes, see if you can get the locations of the branches, just to see if you're getting this. Okay, so pause it now, try that, and then hit play again when you either get stuck or you're done. Okay, welcome back. Hopefully you actually did that and actually paused it and tried this. It's going to make your experience a lot better. So here we go. Let's start by finding our asymptotes. So our vertical asymptote here, our VA, is set the denominator equal to 0 and solve. So we get x equals negative 1. So let me plot that. X equals negative 1. Next, finding the horizontal asymptote. For reciprocal functions like this, we can just take the k value. So that's y equals 3. So let's plot that up here. Okay. And next, we're going to go ahead and plot some points to try to find where, which quadrants these branches are going to be located. Okay, so let's be strategic about the x values we pick. Let's start by picking x equals 0. Okay, x equals 0 is close to the vertical asymptote, and it's also a good point to find. It's the y-intercept. So plug a 0 in for x. 0 plus 1 is 1. Negative 1 divided by 1 is negative 1. Plus 3 gives me 2. Okay, so let's plot that point. When x is 0, y is 2, so it's up here. All right, now think about that point, okay? That point, that branch is going to look something like this, which means the second branch is going to be somewhere up here. Remember, they're always in opposite quadrants from each other, okay? So if one branch looks like this, the second branch is going to look something like that, okay? So let's pick just a few more points here to feel good about being able to draw this graph, okay? Let's pick maybe something over here, okay? So how about negative 2 for x? Negative 2 plus 1 is negative 1. Negative 1 divided by negative 1 is positive 1. Positive 1 plus 3 gives me 4. So when x is negative 2, y is 4. So let's plot that point. Negative 1, 2, 1, 2, 3, 4. Okay? Now, actually, with the location of those 2 points, I feel pretty comfortable drawing those graphs, okay, those branches. Because remember that as you approach the asymptotes, they treat it like a magnet. Okay, treat it like a magnet. The ends are drawn towards the asymptote. Remember, they get really, really close, but they never actually touch. Okay, and we actually, if you want to go like next level transformation stuff, you shouldn't really be surprised that we switched quadrants here to quadrant 2 and 4 because of the negative a value. The negative a value actually reflects this across the y-axis. So, in other words, across the horizontal asymptote. So we shouldn't be surprised that our quadrants have changed there. If that's over your head, don't worry about it. Just keep making your table of values. Okay. Last step here is to write out the domain and the range. Okay. My domain is from negative infinity to the vertical asymptote, which was -1, union -1 to infinity. And the range was from -infinity, which is the floor, all the way to the horizontal asymptote, which is 3. And we go from the other side of 3 all the way to infinity. Now, the last problem I have for you, example 4, is just a graphing matching problem. See if you can do this. You don't have to actually write anything down if you don't need to, but pause the video now and see if you can pick the correct graph that matches with this function. Okay, welcome back. Hopefully you have an answer choice in your mind. We're going to start with the process of elimination here. So real quick, let's talk about our asymptotes. The vertical asymptote is x equals 3, because again, remember we set the denominator equal to 0. The horizontal asymptote for reciprocal functions is just the k value, so that's y equals 3. So what we're going to do is we're going to eliminate any answer choices that do not have the right asymptotes. Okay, so C and D are out of there right away. So now A and B, the only thing that's different between A and B is the location of the branches. Okay, so we've got to figure out which orientation is correct. Now, an easy way to do that is to make a table, okay, and plug in a value. Okay, so let's plug in x equals 4. So plug that in. 4 minus 3 is 1. 2 divided by 1 is 2. 2 plus 3 is 5. So 4, 5 needs to be a point on the graph. So 4, 5 is up here. That is correct. 4, 5 up. And graph A does not have the correct point. Therefore, we're at graph B. Y'all, that's everything that I got for you on reciprocal functions. Remember, find the asymptotes first, vertical and horizontal, and then make a table of values to help you figure out where the two symmetrical branches are going to be located. And then once you have the graph drawn, domain and range is easy. Hope this was helpful. 8.4 is our next video lesson. That's where we're going next. That's on a little bit more interesting rational functions and graphing. It's going to be a lot of fun. I'll see you then.